Hello everyone and welcome to my project presentation on improving the generation of platform artifacts for the HPCC system builds. This project was under the mentorship of Michael Gardner and Ming Wang as part of the 2024 summer internship program at HPCC Systems. The goal of this project is to migrate an existing web service hosted on Jenkins to GitHub Actions, utilizing a Python script that parses the artifacts and generates their metadata in the form of a JSON file. There are several proposed values in this project, including having a more CI/CD practice that leverages GitHub Actions in Python for a more maintainable, flexible automation, which offers developers a more central experience by not having to go back and forth between Jenkins and GitHub. Now the CI/CD pipeline is completely or 100% hosted on GitHub Actions. The second value is having a streamlined workflow, which automates manual tasks to reduce errors and inefficiencies. For example, before, the JSON file had to be downloaded manually and uploaded to AWS to do the synchronization and put the artifacts in the right directory structure. Now it is becoming a part as a step in a workflow rather than doing it manually. The third point is security enhancements by utilizing GitHub secrets. So we're not storing any sensitive data in end file, but rather doing it in the platform directly. It has also been a great learning opportunity for me as an intern, as I have gained more experience across several platforms, tools, and programming languages. I also do believe the community impact is significant, as we have increased the reliability and the efficiency of the HPC system platforms for the open source community. Implementation-wise, we have several functions that have helped us reach this output or the performance that we're going to discuss later. First of all, the GitHub configuration, which utilizes the US library, and then it allows the communication between the Docker container and the script. And then the second function is the extract info, which takes the version and the ID information from the file names using the right regular expressions, and then the map to OS dictionary, which maps the extracted ID patterns with the corresponding operating system information. And then the fourth function here is the filter MD5 assets, which links or maps the particular file to its MD5 some encryption. And then here I have the repo link for any potential developers to make any improvements to the project or any necessary amendments. There's been a lot of reusable components from the previous repo, such as the regular expressions, so we didn't have to reinvent the wheel when it comes to that. And then we also have an OS dictionary correlating the operating system's information with the ID retrieved from the file names. In figure 1 here, we see an example of what the metadata looks like for this particular Debian file, the OS version, all the way to the MD5 sum encryption. More results here on the right. We are looking at a few artifacts and their MD5 sums generated in the GitHub releases. In the third figure, we look at the performance of the parser script, and we see an inline performance or correlation between the number of assets processed and the time needed to process them. So as the number of assets increase, the time increases, but not significantly. It is more inline, so which suggests a more of an n log n or an even linear performance. In figure 4, this is more highlighted. As you can see, when we increase the number of assets, the performance doesn't seem to be anything concerning, such as quadratic or exponential, but rather somewhere between the line of linear and logarithmic, actually. So as a conclusion, this project has upgraded to Python 3, which allows for faster debugging and more aligned with the current HPCC system's tech stack. The usage of GitHub API to upload the assets into the S3 bucket is a better design choice rather than creating a connection between the workflows that would create more development time without any necessity. The third point is that the project automates the package file sync into the S3 bucket as previously discussed. And the migration, again, from Jenkins to GitHub Actions offers better flexibility in terms of not having to deal with several platforms. At the end of my presentation, I'd like to acknowledge the great support from the team, especially Michael Gardner, Ming Wang, Hugo Watanuki, and George Foreman. Thank you very much for attending this presentation. Goodbye.